Hey you guys, welcome back to another video. Today we're going to be covering topic 1.6, polynomial functions and end behavior. The end behavior of a function describes how a function behaves as it moves infinitely to the right and to the left. In other words, the end behavior is what happens to the values of f of x as x increases or decreases without bound. Remember that f of x is also known as your y variables. So your y values can either be going up or down or going to a number. So it just depends what's happening all the way to the left and all the way to the right. Okay, so remember, if you think about the x-axis, all the way to the left, you have the negative numbers, and all the way to the right, you have the positive numbers. So to the left, you're going to be approaching negative infinity, and to the right, you're going to be approaching positive infinity. So if we look at the left end behavior, this is read as the limit of f of x as x approaches. So the arrow is approaches. Okay. So on the left side, you're going to see that it's always going to approach negative infinity because on the left of the x-axis, you have negative infinity as we just discussed over here. Okay. Verbally, you can say as the x values decrease without bound, the y values of f of x, and then you fill in your answer. They could also say instead of x values, they can say input values. So they can say as the input values decrease without bound, and the y values can also be the output values. Okay. Whenever you're doing your limit notation, this should be stacked underneath each other, and you should write them in like a little imaginary square. So don't make your arrows too big. Some kids like to write limit and then they put the x and then their arrow is like this big with the infinity, and then it just gets really long. So you see how this is more of a rectangle? You want it to be a little square like this. So try to make everything tight, but not too tight that it's not legible. Okay. On the right side, so on the x-axis on the right side, you go towards positive infinity. So for your right end behavior, your limit will be as x approaches positive infinity. You can also say as the x values increase without bound, the y values of f of x, and then you put in your answer. Okay. Or again, remember, it could say as the input values increase without bound, the output values of f of x, and then you insert your answer. Okay, so let's do some examples. If you look at this graph, so remember on the x-axis all the way to the left, you have negative infinity. All the way to the right, you have positive infinity. On the y-axis, all the way to the top, you have positive infinity, and all the way at the bottom, you have negative infinity. Okay, so when you're doing your left and right limit statements, the middle of the graph does not matter. Okay, so when you're looking at the left side, and I would recommend grabbing your hand and covering the side of the graph you are not supposed to be looking at. I can't do that, so I'm just going to use my laser to kind of erase all of this. So we're going to focus on the left side. Okay, so I see the left side is going up this way. That means that the left side is going to be approaching positive infinity. Okay, now if you do your right side, then you erase all of, not erase, but use your hand to cover the graph and only focus on the right side. You see how the right side is going down? That means that the right side will be approaching negative infinity. So verbally, I'm going to say as the x values decrease without bound, the y values of f of x, and then because we said that for the left side, we were going up to positive infinity, we're going to say the y values of f of x increase without bound. Okay, so again, as the x values decrease without bound, that means that x is going to negative infinity. The y values of f of x increase without bound. That means that the y values are going up to positive infinity, right? So as we went to the left, the y values went up. Okay, For limit notation, you're going to say the limit. I like to write my limit in cursive because it takes up more space and that gives me space at the bottom to put my x approaches negative infinity. I've noticed that some kids write really small like this, and then when they have to do this part, it doesn't fit. So it's up to you, but I spread out my limit in cursive so that I have more space at the bottom, okay? So the limit as x approaches negative infinity, f of x approaches positive infinity because it went up when I went to the left, right? For the right side, it'll be similar as the x values increase without bound. The y values of f of x decrease without bound. Okay, so as the x values increase without bound, that means that x is going to the right to positive infinity. The y values decreased, so the y values were going down to negative infinity. Okay, right? On the right side, as we went to the right, the y values went down. Okay, in limit notation, you would say the limit as x approaches positive infinity, f of x equals negative infinity, right? So as you went to the right, your y values went down. Okay, let's try another one. So on the left, okay, you can use your hand to cover this. I'm just going to use my laser. You don't want to see the middle and you don't want to see the right. As I go to the left, I see that my y values go up. So for the left side, I know I'm going up. Now I'm going to do the same thing for the right. Now I'm going to ignore everything on the left and on the middle. As I go all the way to the right, I see that my y values also go up. So both of these go up on the left and the right, okay? So the left verbal statement will say as the x values decrease without bound, the y values of f of x increase without bound. The limit notation would be the limit as x approaches negative infinity, f of x is equal to positive infinity. And it'll be similar for the right side as the x values increase without bound. The y values of f of x increase without bound. For the limit notation, it would be the limit as x approaches positive infinity, f of x is equal to positive infinity, okay? So notice, x approaches negative infinity is the left side, x approaches positive infinity is the right side, but both of them were positive infinity because both the left and the right went up to positive infinity, okay? Let's keep going. We're going to sketch a polynomial function with the following end behaviors. Okay, so I see that at the bottom here, I have that as x approaches negative infinity. I know that that's going to be my left limit because on the left side is where x goes towards negative infinity. On the right side, I always have x approaches positive infinity. This is telling me that the y values are going down on both the left and the right. Now, because this is a sketch, all of your sketches might vary, but I'm going to start off with making sure that on the left side, I'm going down, and on the right side, I'm also going down. Now, what you do in the middle is up to you. If you want to do something like this, or if you just want to fill it in like this, or you can do something crazy like this, okay? The middle of it doesn't really matter. I'm just going to do like a little M shape like that, okay? Again, the middle does not matter as long as your left limit is pointing down and your right is also pointing down. That answers the question, Okay, let's try the other one. Okay, I see x is approaching negative infinity. I know that this is my left side. And when it says x approaches positive infinity, I know that is my right side. This one is going down and this one is going up. Okay, so on the left, I'm going to draw an arrow going down. And on the right side, I need to be going up. Okay, now what you do in the middle is up to you. If you want to do a straight line, or you want to do a little curve, or you want to go like this, it doesn't matter. I'm just gonna, that didn't even connect. Let me try that again. It's a little better. Okay, again, the middle doesn't matter as long as you follow the end behavior all the way to the left and all the way to the right. Oh, what happened? It disappeared. There it goes. Okay, let's keep going. Polynomial end behavior. Before we discuss this, I want to go over what a polynomial is. A polynomial consists only of variables with positive exponents and the terms are combined with multiplication, addition, and subtraction. Okay, as an example, we have 5x cubed minus 4x squared plus 3x minus 10. Okay, so notice we do not have any division. The coefficients are multiplied with the variables. The terms are either added or subtracted together. There is no division. All of the exponents are positive integers. We have 3 and 2. Remember, this is an imaginary 1, and there's an imaginary x to the power of 0 there. So they're all positive integers. So what would not be a polynomial is something like this, where you have a negative exponent. And you also can have something like this, where your variable is a variable, or sorry, where your exponent is a variable. Okay, so it needs to be positive integers, so positive numbers as your exponents. Okay, and then no division. So once you recognize that what you're looking at is a polynomial, it is easiest to find the end behavior of the right side first. For the right side, you're going to go to positive infinity if your leading coefficient is positive. And you're going to go to negative infinity if your leading coefficient is negative. Okay, and then just to recap as well, just to review what a leading coefficient is, that is the number in front of the variable with the highest exponent. Okay, so first you need to find the term with the highest exponent, and then the number in front of that is your leading coefficient. For the left side, you're going to go in the same direction as the right if your degree is an even number. And you're going to go in the opposite direction as the right if your degree is odd. And then just to review what a degree is, that's another word to say exponent. Okay? So once you figure out that the number in front of your variable that has the highest exponent, aka your leading coefficient, is positive, you go up on the right. If it's negative, you go down on the right. If your degree is even, 2, 4, 6, 8, then the left side will be the same as the right side. And if your degree is odd, like 1, 3, 5, or 7, etc., then it'll be in the opposite direction. So for even, they'll both be going up or they'll both be going down. For odd, it'll look more like this, where one side goes up, or it can look like that. So they'll be opposite directions. Okay? So let's try example 3. Letter A says f of x equals 4x to the power of 5. Okay? My coefficient is the 4, okay? So my coefficient, my leading coefficient is 4, which is a positive number. That means that my left limit, I'm going to say the limit as x approaches positive infinity, f of x goes to positive infinity. Remember, if your leading coefficient is positive, you go up on the right. So always do the right side first. After you do that, you're going to figure out what your degree is. The degree was 5. 5 is an odd number. That means that the left side will be opposite of the right. So I'm going to write the limit as x approaches negative infinity, f of x equals negative infinity. Okay? So because on the right side we went up to positive infinity, this has to be the opposite, negative infinity. Okay? Let's try another one. We have b here. The leading coefficient is 1/2, which is a positive number. So I'm going to say the limit for the right side as x approaches positive infinity, g of x goes to positive infinity. Now we'll look at the degree. The degree was 4, which is an even number, which means that both sides will be the same. So when I do the limit as x approaches negative infinity, g of x equals positive infinity. So it has to match this one because this is even, which means that they're going to be the same on both the left and the right. Okay, let's try C. Now, for this one, it's kind of hard to see because it is in factored form. Now, this is a big exponent of 6. If you were to multiply this out, you would be writing x plus 3 times x plus 3 times x plus 3, etc., 6 separate times. I'm going to teach you a shortcut to find the leading term. All you're going to do is multiply the leading term of each factor, and that will give you your leading term for the entire polynomial without having to multiply it and get it from factored form to standard form. Okay, so here I have a -2 in the front. This is a factor by itself, and then in x plus 3, the leading term would be x. Okay, because remember, x has an exponent of 1, and this one has an exponent of 0 because there are 0 x's there. So between 1x and no x's, that 1x is bigger. Okay, so x is the leading term, but this is also raised to the 6th power. So what I can do is say -2 times x to the power of 6 would be -2x to the power of 6. Now, this is not the whole factor expanded. It is not the entire thing in standard form. What I'm giving you is just the leading term, right? So maybe it's -2x to the power of 6 plus 5x to the power of 5 plus 3x squared minus 8. You know, something really long, but we don't need this. All we need is the biggest term. The term with the biggest degree is your leading term. So we're not really worried about expanding it fully. Okay? So when you have the leading term, I have the leading coefficient is -2, which means that the left side is going to be going down. So the limit as x approaches positive infinity, y equals negative infinity. And for the left side, we'll say the limit as x approaches negative infinity, y, so let's look at the degree now. The degree was 6, which is an even number. That means that the left side also has to go down to negative infinity. Okay, let's do letter D. Now remember, a whole number has an imaginary x to the power of 0 on it. So between 0 x's and 5 x's, the leading term would be -x to the power of 5. And it's important to take the negative with you, okay? So the leading term is not always the term in the front. It can be somewhere else. It's the one with the highest exponent. Okay, so my leading coefficient is a -1, which is a negative number. So my right limit will say the limit as x approaches positive infinity, h of x is equal to negative infinity. My degree was 5, which is an odd number. So when I do the left side, I'll say the limit as x approaches negative infinity, h of x, it has to be the opposite, so this one will be going up to positive infinity. Let's look at another one. Look at the degrees to find the leading term. We have 2. Remember, there's an x to the power of 0 here. So between 2, 0, and 5, 5 would be the biggest. So your leading term is negative x to the power of 5. So your leading coefficient is -1, which is negative. So you do your right side first. The limit as x approaches positive infinity, k of x equals negative infinity. Now for the degree is 5, which is odd. So I know the left side is going to go in the opposite direction. So the limit as x approaches negative infinity, k of x equals positive infinity. Okay, last one. So again, this one is in factored form. If you want to, you can distribute this and multiply everything out and get it in standard form, but you only need the leading term. So to find the leading term in factored form, you can get the leading term of each individual factor and multiply those together. So 2x is the term by itself. Between x and -1, x is bigger. And between 6 and negative x is bigger. So what I'm going to do is 2x times negative x. Okay? That gives me negative 2x cubed. So my leading coefficient is -2, which is negative. So I know that my right limit will go down to negative infinity. So the limit as x approaches positive infinity, m of x equals negative infinity. For the left side, the limit as x approaches negative infinity, m of x equals, and now let's look at the degree. The degree was 3, which is an odd number. So my left has to be opposite, so it'll go up to positive infinity. Okay, let me zoom out a little bit. So again, just do the right side first. See if your leading coefficient is negative or positive, and then if your degree is even or odd, will determine if the left side matches or if it's the opposite. Okay, let's keep going. We're going to write limit statements for the following polynomials. It's the same thing. My leading coefficient is -3, which is a negative number. Okay, so I'm going to write my limit statements. Well, let's start with just writing it out. So usually we write the left side first. Okay, I'll come back and fill them in. Okay, so this is my left limit and this is my right limit. Okay, so remember the left is always as x approaches negative infinity and the right side is always positive infinity. Okay, so back to the leading coefficient, we had a -3, which is negative. So the right side will be going down to negative infinity. The degree was 4, which is an even number, which means that both sides will be in the same direction, so the left also has to go down to negative infinity. Okay, now let's look at B. The leading term here, remember that x7 is being multiplied by x to the power of 0. So the term with the highest degree would be 5x cubed, making that your leading term. The leading coefficient is 5, which is a positive number, and your degree is 3, which is an odd number. Okay, so let's write our limit statements. As x approaches negative infinity, g of x equals something. This is for the left side. And for the right side, it will be the limit as x approaches positive infinity, g of x equals something. Okay, my leading coefficient was positive, so I know the right side will go up to positive infinity. And because the degree was odd, I know the left side will be opposite. It will go down to negative infinity. Okay, now when you're writing your answers, you wouldn't normally include this. If they ask you, write the limit in limit notation, you're not going to say left and then colon and then all of this. You're only going, this is your final answer. You would not include the left and the right there. Like that would be a given for whoever is reading it. Okay, let's try example 5. Use a graphing calculator to determine the end behavior for the following functions. Well, a is a polynomial. I know that 3x is being raised to the power of 1 and this 1 is being raised to the power of 0. So I know my leading term would be x squared. My leading coefficient would be 1, which is a positive number, and my degree, which is 2, is an even number. So if I write the limit, let me just write the limit statements first, and then we'll go back and fill in the answers. Okay, so you always do the right side first. My leading coefficient was positive, so the right goes up to positive infinity. And the degree was even, so the left will be the same as the right. So they both go up to positive infinity. Now let's graph it and see if that's correct. Okay, so we had x squared minus 3x plus 1. Okay, and if you can see, both of those go up to positive infinity. If you want to sketch this in your notes, you can. It'll look something, oh, not like that. It needs to be more curvy, like this. Okay, let's try letter B. Now, B is not a polynomial function because I see division. Okay, so I cannot use the methods of finding the leading coefficient and the degrees. I'm actually going to teach you how to do this by hand in lesson 7, but for now we'll rely on the calculator to see what the limit would be. Okay, so let's go ahead and graph this. So in the numerator we have 2x minus 3, and in the denominator, what happened? Let me try this again. 2x minus 3. Why does it keep doing that? I'm sorry. Oh, I didn't mean to put a. In the denominator, we have x plus 1. Okay, this is what it looks like. Now I can keep zooming out. And it's kind of hard to see on this graph, but there's actually a horizontal asymptote at y equals 2. And I'm going to go ahead and graph it so you can see it. If I just put 2, you see how that line at 2, this doesn't touch it? That means it's a horizontal asymptote, and the same thing here. So remember that asymptotes are imaginary lines that your graph will not intersect. So for the left side, we're going to ignore everything on the right and in the middle. So what I'm going to do is I'm just going to zoom out over here. You see how the graph doesn't go up or down? It stays hovering right above the horizontal asymptote. That means that for this type of function, it's actually going to approach the horizontal asymptote on both the left and the right. So if we look at the right, the same thing happens. You're getting really, really close to it. You don't ever touch it, but you just keep kind of hovering right over it forever. Okay, so I'm going to go ahead and sketch this in the notes so you can have it. And then there was a horizontal asymptote at y equals 2. And then the graph. This is a rough sketch, but it looked something like this. Okay, so for the limit statements, we'll say the limit as x approaches negative infinity, and we'll say g of x equals, and we'll come back and fill it in, the limit as x approaches positive infinity, g of x equals something. Okay, so remember, as you looked all the way to the left, the pink line, which is the graph, you didn't see that arrow going up and you didn't see that arrow going down. So you cannot say positive or negative infinity. Rather, because it always stayed hovering on top of the horizontal asymptote, we're going to say that it approaches the horizontal asymptote, which is at 2. Okay, and the same thing for the right side. It stays hovering on the horizontal asymptote all the way to infinity. That does not go up and it does not go down. It stays just horizontally approaching 2 all the way to the right. okay? So this is actually called a rational function, which is a sneak preview of what you're about to learn for the better half of the Unit 1. So lessons 7, 8, 9, 10, and 11 all have to do with rational functions. So this is a little sneak preview, okay? Let's do letter C. We have negative 10x squared. So let's go ahead and graph it and see what that one looks like. Negative 10 divided by x squared, and it looks like this. Now you can see there's a horizontal asymptote at 0. I can go ahead and graph 0 if you want, so you can see it. There it is in green. So it's the same thing. So all the way to the left, you see how it's approaching 0. It never touches it, but it's going to keep getting really, really close. And then all the way to the right, the same thing happens. It's approaching the horizontal asymptote at 0. You never see that graph going up or down, okay? So let's go ahead and sketch this one. And then there's a horizontal asymptote at 0. And then the graph looks something like this. So for the limit statements, we have the limit as x approaches negative infinity, h of x equals, and then the right side, the limit as x approaches positive infinity, h of x equals, okay? So just like the other one, you don't see the pink line going up or down, okay? So if it's just, going constantly forever, that means it's hovering the horizontal asymptote, which was at 0, and the same thing on the right, which is 0. So B and C are not polynomial functions. These are actually rational functions, okay? And we'll go into detail on this on lesson 7. So you can watch that video and I'll go into this in more detail. But yeah, I hope this video made sense. Let me know if you guys have any questions and I'll see you in the next video. Bye.